Okay, so very good evening to the student who have joined. Can you kindly let me know in the chat box if my voice is audible and the videos is visible? The students who have joined, kindly let me know in the chat box if my voice is audible and the screen is visible to you. Okay, so for the smooth ongoing of the class, I have just muted all of you, and so if you have anything to tell me, okay. Okay, so if you have anything to tell me, you can just write in the chat box. Okay, so is my voice audible to you, and is the screen visible? Okay, thank you so much. So welcome in the class. I will just wait for a few minutes, let other students join, then we will start today's session. Meanwhile, if you have any problem by listening my voice and for seeing the PPT, please kindly let me know in the chat box. Okay, for the smooth streaming of the class, I just have muted all of you. Yeah, very good evening, Stephen. So if you have anything to tell me, you can just write in the chat box. Okay, at the end I will just, okay, Sneha, I think you have something to tell me, so can you please just write it in the chat box? It will be easier to me to handle the class, that's why I have just muted all of you. But the chat box is always open. I am always checking the chat box. So if you have anything to tell, if you want to tell me anything, you just can use the chat box. Let us wait for a few more minutes. Let more students join, and then we will start today's session. Okay, so very good evening to the students who have joined the class till now. My name is Mousumi Deb, and I am a PMRF fellow from the Department of Chemistry and Chemical Biology, IIT ISM Dhanbad. I will be your TA for the course of NPTEL course of Organic Chemistry in Biology and Drug Development for this semester. So today it is our first week 1 live session. So before starting, I just want all of you to know a few things about the class. First, I have muted all of you because okay, let me admit. So I have muted all of you because I want the class to have a smooth streaming. So if you have anything which you want to tell me during the class, so you just send a message in the chat box. Okay, I am always monitoring the chat box. So if you have anything to tell me, you can just write in the chat box. I will just answer the questions. Okay. So today it is our first session. So before starting the session, yeah. So okay, Sneha, you want to tell something? Just can you just write in the chat box? Okay. If you have anything to tell me, you can just write in the chat box. Because it will be easier for me to see if everybody have any problem. So I think my voice is audible and clear to all of you, and the slide, it is visible. So can somebody just confirm if you can see the slide and the PPT? just let me know in the chat box if the slide is visible. Okay, so can somebody just let me know if my slides are visible, the presentation is visible or not? Yeah, okay, so thank you all of you. So let us start our class. Eventually when other people will join, I will just I will just add them, okay? Okay, so let us start today's session. So again, very good evening to the students who have joined. As I said, today it is the week 1 live session for this NPTEL course of organic chemistry in biology and drug development. Every week on Tuesday, we will have this kind of problem solving session from 6 p.m. to 8 p.m. Okay, the sessions it will be live on the Google Meet platform. If any network disruption happens during the class, I will request all of you to wait for few minutes. Do not leave the class. Okay, I will join as soon as possible, and if there is any network issue from your side, so don't worry. To the slide, this presentation and all this class recording will be shared to you by the NPTEL site. Okay. During the session, the students can post their question and doubts through the chat box, and if still any doubt persists after class, the students can drop an email to me. I will share my email ID with all of you at the end of the class, and if you have any doubt, any query which is not answered during the session, you just can drop me an email. I will just answer you in the due time. Okay, so do not worry about it. Today it is the first your live session class, and in this session we will discuss 2 weeks course content. Means we will discuss your week 1 and week 2 course content, and this class will help you to solve your weekly assignments. So I think you already 2 weeks assignments are there, week 1 assignment and week 2 assignment on the NPTEL website. So in today's class we will discuss the course content of week 1 and week 2 from this course organic chemistry in biology and drug development. Okay, so in this class what we will do, we will discuss few MCQs. Okay, we will discuss around 20 MCQs today. First I will show you the question. Okay, after showing you the question I will give you some time, and in this time what you have to do, you have to try to answer that question, and you can write your answer in the chat box. Okay, after showing you the question I will wait for 2 to 3 minutes. If you know the answer, and if you don't know the answer, that's all, that's also fine if you don't know the answer, but I want all of you to at least try to answer these questions. Okay, so what you have to do, whatever you think is the correct answer, you just put the answer in the chat box, like the A, B, C or D. Okay, after showing you the question, what I will do, I will just check what is the answer is given by you. Is it may be wrong, it may be right, it does not matter, since it is only the your session class, it is not your assignment. Okay, there is no marks on these question, but it is only for your learning. So what we have to do, after I check your answer, it does not matter if it is correct or wrong, then we will discuss that particular question and the things related to that. Okay, so I think it is clear to all of you, like what we will do in today's class. Okay, so let's go back into the presentation mode. So as I said, today we will discuss 2 weeks course content. So in the week 1, the course contents are like this: a brief introduction to molecules of life, structure of amino acids and their various charged forms, biological macromolecules and small molecules, importance and functions, amino acids, the building block of the proteins, amino acids, separation and detection, electrophoresis, Nein-Hydrin reaction. And in the week 2, the course contents are like this: method of determination of amino acid sequence, primary structure of the polypeptide and protein, selective peptide bond cleavage, enzymatic and non-enzymatic methods, peptide synthesis, protecting groups for amine and carboxyl functionality, peptide synthesis, protection, coupling, deprotection methods, and recent development of coupling reagents like Merrifield method of solid phase peptide synthesis. Okay. So, these are your course content which we will discuss today. Okay, so I think it is clear, the instructions are clear with all of you. Is there any doubt till now whatever I have shared with you, or can we just go to the questions right now? If you have any doubt, okay, so if you have any doubt, like I have always said, please do write in the chat box. Okay, I will just answer your query because I am always checking the chat box, so don't worry about it. If you have any doubt, any query, I have just muted all of you, so the class, I mean the streaming can be clear. Okay, so now I think we can start today's class. So as I said, I will show you the question and I want all of you to try to answer the question. Okay, so the first question of today's session is problem number 1. Which of the following is not an essential amino acid? Your options are number A alanine, number B methionine, number C valine, and number D histidine. So now I want all of you to try to answer this question. Which option all of you think is correct? Means which of this following 4 amino acid is not an essential amino acid? Try to answer this question in the chat box. Take 1 or 2 minutes. Somebody wants to join, I think. Okay, one more thing. I also want you one thing, like please read the question carefully. Okay, this type of question, and please always read the question carefully. It is saying that which is not an essential amino acid. So I think I have few answers for this question. Okay, there are few B and one A and one D. Okay, so let us check what is the correct answer. Okay, so the correct answer of this question is number A alanine. Alanine is not an essential amino acid. So let us see what is an essential amino acid and what is the role of it. Okay, so essential amino acids. An essential amino acid is an amino acid that cannot be synthesized itself by the organism, is usually referring to humans, and therefore must be supplied in the diet. 10 amino acids are essential amino acid. They are arginine, histidine, leucine, isoleucine, lysine, methionine, phenylalanine, threonine, tryptophan, and valine. These amino acids must be obtained from the diet. An adequate diet must contain these essential amino acids. Typically, they are supplied by meat and dairy products. Essential amino acids help the body function and regulate neurotransmitters, chemicals in the brain that control mood and behavior. A lack of essential amino acids can cause emotional or physical difficulties and lead to the health disorder. Okay, so among these 4, alanine is not an essential amino acid, but methionine, valine, and histidine, these are essential amino acids. Okay, so there are one more form like this. This is a trick by which you can remember the name of these amino acids. Like any help in learning, these little molecules proves truly valuable. So as you can see, all the first letters of this line are denoting one amino acid, like A for arginine, H for histidine, I for isoleucine, L for leucine, 3 for threonine, L for lysine, M for methionine, P for phenylalanine, T for tryptophan, and V for valine. Okay, so that's how you can remember it more easily. So it does not matter how you remember these things or how you want to remember this thing. It's completely up to you, like how you will feel. Okay, comfortable remembering these things. So this was the first question. Okay, so very good that all of you tried to answer it. Does not matter, as I have always said that it does not matter if the answer is correct or wrong, but at least everyone should try to answer the question. Okay. So this was all about the essential amino acids. Now problem number 2. Problem number 2 says that which of the following statements is true regarding the peptide bond formation? Number A. The carbonyl is syn to the hydrogen of NH bond. Number B. Carbon-nitrogen bond is purely single bond in nature. Number C. FMOXCl is used to form peptide bond. And number D. Hyperconjugation effect is reduced when hydrogen of NH bond is replaced by R groups. Now this is a true false kind of question. So it is very important during the true false kind of question, like you have to, okay. So it is very important during the true false kind of question for all of you to read the question very carefully, because most of the student I have seen like they get confused during the true false kind of question. So by reading the question repetitively is very important. So all of you know what is a peptide bond, like in the amino acid there is a carboxylic acid group and then there is a amine group. Okay, and when the both functionalities react, we have this kind of peptide group. There is a carbonyl carbon and there is a NH group. So this question is regarding to this peptide bond functionality. So read all the question, all the options carefully and then tell me which of the following you think is the correct answer of this question. Which of the following statement is true regarding the peptide bond formation? Carbonyl is syn to the hydrogen of NH bond. Carbon-nitrogen bond is purely single bond in nature. FMOXCl is used to form peptide bond. Hyperconjugation effect is reduced when hydrogen of NH bond is replaced by R groups. Try to answer this question in the chat box. After that I will, after showing you the answer, I will discuss about the peptide bond and the functionality and everything. Okay. So are there any answers? Okay, so it's D, it's D, it's D. I think it is, so we have few answers like D and B being the most common ones. Okay, so very good. Let me see which is the correct answer, then we will discuss about it. Okay. Okay, so the correct answer is, yes, it is number D. Hyperconjugation effect is reduced when hydrogen of NH bond is replaced by R groups. Okay, so this statement is true. Now let us see what is about the peptide bond. So as you can see here in this figure, this is your peptide bond. So there is a carbonyl group and there is a nitrogen, and these are two amino acids for about two different amino acids. Okay, so what happens, the first statement is the carbonyl group is syn to the hydrogen bond, hydrogen of NH bond, which is wrong, because here you can see the NH bond and carbonyl carbon bond, they are not syn, they are anti, means they are pointing at a two different side. The angle between these two is 180 degree. Okay, so carbonyl group is facing this side and NH group is facing this side. The angle between these two is 180 degree, means they are anti. So they are not syn. So first statement is wrong. The second statement says that the carbon-nitrogen bond is purely single bond in nature. But as you can see here, there is the resonance happens here. Their nitrogen have some lone pair. Okay, due to this lone pair of nitrogen, nitrogen can donate the lone pair to this carbon-nitrogen bond, and this double bond can be broken, and there is this kind of plus minus structure where the carbon-nitrogen bond gets a double bond character. So statement number B, like the carbon-nitrogen bond is purely single bond in nature, it is also false. Now FMOXCl is used to form peptide bond. This is also not correct. FMOXCl is a very important reagent in the peptide chemistry, but what is the role of this reagent? It is not for the peptide bond formation. What is the exact role, that I will discuss you later today. Okay, so don't worry about it. So there are many reagents which can be used for peptide bond formations, like there are DCC, there are PIBOP, there is HBTU. Okay, this kind of reagents can be used for peptide bond formation. We will discuss that also in later today's class. And the last statement, hyperconjugation effect is reduced when hydrogen of NH bond is replaced by R groups. It is correct. So if you know about the hyperconjugation, you will see like the NH bond, it has more donor tendency than a NR bond. Okay, so that's why what will happen if you replace this NH by NR, if you replace this hydrogen by R group, which R group has a plus I effect. You all know that this R group has a plus I effect. That's why the hyperconjugation will not be that great like for the NH bond. Okay, so this statement was correct. So I think almost all of you have given the correct answer for this question. So very good. So this was the problem number 2. So do you have any question or any query related problem number 2, or everybody understood what I have said right now? See, if you have any doubt or any query during the class, please let me know in the chat box. Okay, at the end of the session and in between the session also, I will try to answer all of your queries. Okay. So now I will just move toward your next problem. Okay. Okay. So this was your problem number 2. Now problem number 3. It says that for the peptide as shown below, each pK value is mentioned. The isoelectric point will be, and there are some options are given, like this is a mathematical question. Okay. So the options are like this. So this is the peptide. So there is a plus charge NH3 group here, plus charge NH3 group here, there is a carboxyl group here and a carboxyl group here. So the pK values for all of this hydrogen, like the hydrogen of this carboxylic acid and the hydrogen of this protonated NH3 is given here in the blue. Okay. So you have to identify what is the isoelectric point for this peptide, and your options are number A 6.3, number B 2.52, number C 7.09 and number D 9.74. So just try to calculate this question. I will just, after the showing you the answer, I will discuss in detail what is the isoelectric point and how isoelectric point is calculated. Okay. But first I want all of you to at least try to answer the question. If you know how to solve this type of problems, then you can I think answer this question very easily. If you don't know, it is fine, because I will show you just now like how it is solved, and we will have this kind of mathematical question today's session later word also. So if I show you one answer, I think you will be able to answer other questions also. Look at the structure very carefully and think what is the isoelectric point of amino acid is. So has anybody solved this question? Okay, I think I have one answer which is saying it is C. We will check. Okay, so don't worry, this kind of mathematical question I will just show you how to answer this question. Okay, so first let me show you the answer of this question, then I will discuss in detail what is the isoelectric point and how the isoelectric point is calculated. Okay, so the correct answer of this question is number A 6.30. Now let me show you what is isoelectric point and how to calculate an isoelectric point. So typical amino acids are Zwitter ions at neutral pH. An internal acid base reaction between the basic amino group and acidic carboxylic acid results in a salt with 2 point charges, but the net charge is 0. A typical amino acid have two acidity constant Ka, one for carboxylic acid group which is Ka1 and for ammonium salt which is Ka2. So as you can see, this is the Zwitter ionic form. Okay, so this is the Zwitter ionic form. In this this Zwitter ionic form stays in the neutral condition where there is no net charge on this amino acid, As you can see here, the carboxylic acid group, it is in the negative form and the amine is in the positive form. Okay, means amine is in the NH3 plus and carboxylic acid stays as COO minus. So, the net charge of this amino acid is 0. Okay, and it is called the Zwitter ion. Zwitter ion means plus and minus both stays in the same molecule. So, if the conditions are acidic, what will happen in the acidic condition? The carboxylic acid group will be protonated. Okay, and in the basic form, basic condition, what will happen? The amine group will be deprotonated. Means in the acidic condition, the net charge will be plus 1, and the basic condition, the net charge will be minus 1. So, yeah. So, in the acidic condition, the net charge will be plus 1, and in the basic condition, the net charge will be minus 1. So, the Zwitter ion is so isoelectric point is of an amino acid is the pH when the net charge is 0. Okay. For amino acid, non-acidic, non-basic side chain, the isoelectric point can be calculated by averaging the two pKa values. The pKa1 is the carboxylic pKa of carboxylic acid, pKa2 is the pKa of ammonium ion. So, Pi will be the average of these two. Okay. So, the amino acid with acidic and basic side chain have 3 pKa values. Pi of the acidic amino acid can be obtained by averaging the two most acidic pKa value, and Pi of the basic amino acid can be obtained by averaging two least acidic pKa value. So, this is about memorizing, but I do not want all of you to memorize this thing. I want all of you to understand how it is calculated. Now, so in short, what you have to remember, like isoelectric point of amino acid is that pH when this line is very important, like the isoelectric point of an amino acid is the pH at which it bears net charge of 0. Okay. Now, look at this structure very carefully. We have 4 pKa values, like, so we have, this is the pKa1, this is the pKa1, this is the pKa number 2, this is the pKa number 3, and this is the pKa number 4. So, as you can see, this is the most acidic pKa. Okay, sorry, I have to just erase it. So, as you can see, this is the most acidic one, then this, and this is the most basic one. Okay. Now, if you think, if I just increase the pH gradually, okay, so the lowest one is 1.88, then it is 3.65, then it is 8.95, and then it is 10.53. Now, if I gradually increase the pH, what will happen? Which which side chain will be deprotonated first? It is this one. This one will be deprotonated first. Now, as you can see, when this is like in this form, what is the net charge? The net charge is plus 2. Here is plus 1 and here is plus 1, right? So, the net charge is plus 2 when this is in this form. Now, if I increase the pH, so what will happen? First, this carboxylic acid group will be deprotonated, means this will stay as COO minus. Now, what will be the net charge? The net charge will be plus 1, because we have plus 1 here means plus 2 and minus 1 here. So, the net charge will be plus 1. Now, if again I increase the pH, what will happen? Then this carboxylic acid group will be deprotonated, this one. Okay. Then what will happen? Then what will happen after the deprotonation of the second carboxylic acid group, means this, the net charge will be 0, right? Because this one is plus 1, this one is plus 1, but this one is minus 1, this one is minus 1. So, the net charge will be 0. Again, if we increase the pH, what will happen? When this amine group is deprotonated, the net charge will be what? The net charge will be minus 2 plus 1 means minus 1. So, from this pH to this pH. Now, look at the structures very carefully. When the pH changes from this to this, the amino acid's charge became plus, gradually from plus 1 to 0 to minus 1. Okay. So, isoelectric point will be the average of these two pKa values, this 8.95 and 3.65, because in this particular transition from 3.65 to 8.95, the amino acids, it stays as a zwitter ionic form, means the net charge is 0. Okay, that is why the Pi will be, exact Pi will be 8.95 plus 3.65 divided by 2 means 6.30. Okay. So, this is about the how to calculate the isoelectric point. I know this may be little bit critical because this calculation part is little tough about the isoelectric point. See, when there is a neutral amino acid like glycine, let me tell you, like glycine have only 2 pKa values, okay, for alpha amine group and alpha carboxylic acid group. So, calculating the Pi value, the isoelectric point value for the glycine, it is very easy, because you just have to average these two things, okay. But when there is a acidic side chain or basic side chain or multiple side chain like this particular problem, so the calculation becomes a bit tricky. Then you have to just check when the amino acid, particularly amino acid, is getting neutral, okay, and you have to average the particular pKa values. Okay, so don't worry about this question. We will discuss this Pi calculation questions more in upcoming questions. Okay, so don't worry about this. So I think some of you have understood this problem, some of you may not understood this problem, but it is fine, because I will discuss similar problem in more elaborated way in the next few slides. Okay. So now I will move toward the problem number 4. So problem number 4, it says that which of the statements about lipid, which of the statements regarding lipid is not true. Okay, again I am saying this is a true false kind of question. So whenever I am showing you a question, please read the question carefully. Here it is needed, which of the statement is not true. Your options are: number A, it is main component of the cell membrane. Number B, it includes fats, oils, steroids and waxes. Number C, most of the lipids are water soluble. And number D, lipids also have important role in cellular communications. From these 4 answers, you have to identify which is not true, means which is false. So it is regarding lipid. I think we all know lipid is a very important macromolecule. So read the options carefully and let me know in the chat box which of the following statement you think is not true regarding lipid. It does not matter if your answer is correct or wrong, but please try to answer the question, okay. Which of the following statement regarding lipid is not true? Number A, it is the main component of cell membranes. Number B, it includes fats, oils, steroids and waxes. Number C, most of the lipids are water soluble. Number D, lipids also have important role in cellular communications. So is there any answer till now? Number C, number C, number C. Okay, I think all of you have answered it, number C. So let me check what is the correct answer. So the correct answer is yes, very good, number C, most of the lipids are water soluble. This statement is not true, this statement is false. Now let us see what is lipid and why it is very important component. So what are lipids? Lipids are macromolecules made of fatty acid monomers. Function of lipids include the structural support for the cell, energy storage and cell signaling. Lipids are typically non-polar in nature, do not interact with water, though some exceptions exist. Main types of lipids are triglycerides, phospholipids, steroids and waxes. Okay. So I think this question was rather simple regarding lipid, and all of you have answered it correctly, which is very good. Okay. So that is all about lipid. Lipid is a very important macromolecule and it is the main component of the cell membrane. Fats, oils, steroid, waxes, all are a type of lipids, but lipids are very important role in cellular communication, energy storage, cell signaling, but they are non-polar, means they are not they do not interact with water. Okay, like we all know, like oil and water, they do not mix. Lipids are just like oils, they do not interact with water. So this was the incorrect answer, incorrect option. Okay, so very good. Now I will move toward the next problem. Problem number 5. It says that which amino acid will move toward the positive electrode at pH 5 during paper electrophoresis? Your options are lysine, histidine, aspartic acid and arginine. Again, this question is somewhat related to the isoelectric point of the amino acid. Okay. So you don't need to, I think, memorize all the isoelectric points of the amino acids, but you must have some intuition regarding the isoelectric points of the amino acid. So will it be in the basic side or will it be to the negative side, I mean the acidic side, means will the isoelectric point will be lower than pH 7 or greater than pH 7? You have, I think you should have some insights about it. And how you will have this kind of insight? You have to check if the particular amino acid is an acidic amino acid or a basic amino acid, or it is a neutral amino acid. Okay, like neutral amino acids, they do not have the acidic or basic side change, but acidic or basic amino acid, they will have some extra side chain which will have some extra charges. Okay, so in this question it is asked which amino acid will move toward the positive electrode at pH 5 during paper electrophoresis. Try to answer this question. After your attempt, I will just discuss what is a paper electrophoresis and how you will identify the correct answer of this type of question. Just try to answer it in the chat box. Does not matter if your answer is correct or it is wrong. But I want all of you again to try to answer the question. Look at the options very carefully. Let me check if there is any correct answer or any answer for this. Okay, I think there are few answers. So this is C, C, C. I think C is the most given answer. So let me check. I don't know if the C is from previous one or this one. So let me check. Okay. Yeah. Okay. Let me check what is the correct answer. Okay, very good. The correct answer is number C, aspartic acid. Now, how you will understand this type of question? Okay. So what is paper electrophoresis? Let me show you first. So paper electrophoresis is a separation technique. Mainly it is used to separate amino acids, protein and peptides. Separation of a mixture is based on charge and size of the molecules. Migration of charged particle takes place through the paper under the influence of the electric field. The paper strip used must contain at least alpha cellulose at percentage of 95% and it should have a slight adsorption capacity. Paper does not contain charge that interfere the separation of the compound. So this is a brief about the paper electrophoresis. Now you don't need to memorize the technique of paper electrophoresis, but you should know how this thing happens. So basically we all know that amino acids are charged, right? So this charged particles can migrate through a paper from a mixture of a solution through a specific type of paper which will have at least alpha cellulose percentage 95. Okay. So when there is a mixture of amino acids, based on the charge of this amino acid, particular amino acid's charge, there is separation will happen. Means some amino acid will move toward the positive electrode and some amino acid will move toward the negative electrode. Okay. So how it will happen? So if pH is less than isoelectric point, then that will be present in a positively charged species. Okay. And if the pH is greater than the isoelectric point, then that will be present as a negatively charged species. So suppose there is a amino acid, so if the pH of the solution, like here in the question the pH is 5.00, okay, the pH of the solution is 5.00 according to the question. Now among these amino acid, if this pH is less than isoelectric point, then it will stay as a positively charged species, means it will go to the negative electrode. But if the pH, this pH is greater than the Pi of the amino acid, then it will present as a negatively charged species and it will go to the positive electrode. Okay, so the Pi isoelectric point of lysine, histidine, aspartic acid and arginine are respectively 9.74, 7.59, 2.77 and 10.76. See, I have just colored every amino acid with their isoelectric point separately, so you can just correlate with them. So, the Pi of isoelectric point of lysine is 9.74, histidine is 7.59 and arginine is 10.76. So, these three, all we know that these three are basic amino acid. This lysine, histidine and arginine, these are basic amino acid, means they have some basic side chain which are extra positively charged. What that does mean, that means like for these three basic amino acids, the Pi values are greater than 7. Okay, as you can see, the Pi values are on basic side, like 9.74, 7.59, 10.76. Okay, so all these three Pi values are greater than the pH of 5, means the pH is less than the Pi for these three amino acid, lysine, histidine and arginine. So, if the pH is less than the isoelectric point, they will present as positively charged species, means they will go to the negative electrode. Okay, means these will go to the negative electrode. Okay, and if for only aspartic acid, only, as you can see, the isoelectric point is 2.77, means the pH is greater than isoelectric point, 2.77, it is actually the isoelectric point, and the pH is greater than this isoelectric point. The pH is given, pH is 5, means aspartic acid will present as negatively charged species and it will go to the positive electrode. Okay. So, you do not need to memorize the exact Pi of the amino acid, but I think you should have some insight about the pH, means the pH, is the pH in the range of basic side, or is the pH Pi will be the acidic side. Okay. So, that is how you will understand by remembering which are the acidic or which are the basic amino acid. These type of question, let me tell you, this kind of question about the electrophoresis and the Pi related question, they will be mostly asked from the acidic or basic amino acids only. Okay. So, you have to remember these things very carefully. Okay. Since aspartic acids, the pH is 5 of the solution, but the Pi value is less than 5. So, it will present as negatively charged species and it will go to the positive electrode. Okay. So, this was the problem number 5. So, I think it is clear, the problem number 5. As I have said, you have to tell me what is your problem in the chat box. Okay. If you have any doubt, any query, if you want me to repeat something, just let me know in the chat box. Okay. At the end of the session or in between, I will repeat that thing. So, this was the problem number 5. Now, we will move toward our next problem. So, problem number 6, it says that what are the 21st and 22nd amino acids that may be incorporated in the proteins. As we all know, like there are 20 most common amino acids, okay, which are incorporated in the protein, but there are 2 more amino acids which are 21st and 22nd amino acid which may be incorporated in the protein. They are rather a little bit of not so much natural, okay, not present in the nature very much, but they are actually, they exist. So, you have to identify what are they. Number A, selenocysteine and pyrrolysine. Number B, selenocysteine and hydroxyproline. Number C, hydroxyproline and pyrrolysine. And number D, none of the above. So, you have to identify what are the 21st and 22nd amino acid that may be incorporated in the proteins. Again, I want all of you to try to answer the question in the chat box. Whatever you think is the correct answer, please write in the chat box. What are the 21st and 22nd amino acids? Number A, selenocysteine, pyrolysin. Number B, selenocysteine and hydroxyproline. Number C, hydroxyproline and pyrolysin. And number D, none of the above. So, are there any answer in the chat box? Let me check. Okay, 6A. So, we have two answers and both of the answer it is saying that it is number A. Okay, let me check. See, I want all of you to participate in the answering, okay, because this is there is no marks on answering this question. Your answer may be wrong, but participating is very important, okay. Otherwise, I won't understand if you are understanding or not. So, I will request all of you, please try to answer the question. If you do not know the answer, still it is fine, but still I want all of you to answer, okay, because there are no marks answering this question, okay. But your assignments, if you answer right now, it will help you only for answering your assignments. So, let us check what is the correct answer. So, yeah, very good. The correct answer is number A, selenocysteine and pyrolysin. So, selenocysteine and pyrolysin, these are 21st and 22nd amino acid that may be incorporated in the proteins. So, what are the structure of this selenocysteine and pyrolysin? This is the structure of selenocysteine. Like we all know what is the structure of cysteine. The cysteine have a side chain, sulfur side chain, okay. So, in the cysteine, the structure of cysteine is like this. Carboxylic acid we will have here, we will have amine here, NH2, and we will have actually here we will have SH, a thiol group. There will be a sulfur in place of the selenium. So, selenocysteine is where there is sulfur is replaced by the selenium, it is selenocysteine, which is your 21st amino acid, okay. And what is the 22nd amino acid? It is the pyrolysin, okay. So, in the lysine, as if you know the structure of lysine, there is this group is not present here, okay. But in pyrolysin, this particular group is present and it is a basic amino acid, okay. There is a extra amine groups, extra nitrogens present here. So, this is the basic amino acid. So, these are the 21st and 22nd amino acid. If you can remember the structures, it will be good. If you cannot remember the structure, it is also fine. It is only for your knowledge, okay. So, now I will move toward the next problem. Now, problem number 7, it says that which of the following statement regarding the ninhydrin test is true? If somebody wants to join. Okay. So, I was in question number 7, let me show it again. Okay. So, the question number 7, it says that which of the following statement regarding the ninhydrin test is true? Number A, all amino acids give the same color in the ninhydrin test. Number B, the color depends on the R group of the ninhydrin test in the ninhydrin test. Number C, proline gives brownish yellow coloration. And number D, all of this. So, ninhydrin test is a very important and very well known test for the amino acids. Actually, ninhydrin test can be performed on any amines, okay. So, this is a very good reagent for just understanding or for seeing the color of the amine. It is a coloring reagent, you can say. So, ninhydrin test is a very important test for the amino acids, and you have to identify among these 4 options which is the true. Again, this is a true false kind of question, but here you are asked what is the true statement. Number A, all amino acids give the same color in the ninhydrin test. Number B, the color depends on the R group in the ninhydrin test. Number C, proline gives brownish yellow coloration. And number D, all of these. I want all of you to try to answer this question regarding ninhydrin. I think ninhydrin test is a very well known test, and this stays in the syllabus, very important in the bioorganic syllabus. So, what is the correct answer? Number D, we have one C, again C, okay, 7C. So, we have C and few number D, A number D and then C. Okay, let me check what is the correct answer, then we will discuss what is the ninhydrin test and how it is done. Okay. See, that's how the class should go. Like all of you tried to answer this, which is very good. Okay, does not matter if your answer is correct or wrong, but I want all of you to participate. So, let us see what is the correct answer for this question. So, the correct answer is yes, number C, proline gives a brownish yellow coloration. So, ninhydrin is a particular compound which reacts with an amino acid and gives a particular color. So, the most common color for the ninhydrin test is bluish violet or a purplish color. Okay. So, how it happens? This is the structure of the ninhydrin. As you can see, this is the ninhydrin and this is a amino acid. Okay. And that is how the reaction happens. First, what happens, like this intermediate amine is formed and there is a aldehyde present. Okay. And this after reacting with the amino acid, this intermediate amine is formed from the ninhydrin, and this intermediate amine, it reacts with another molecule of ninhydrin, and this kind of a structure is formed, which is called the Rueman's purple. And due to this particular compound, almost all amino acids show a bluish violet color from the ninhydrin test. Okay. But there is one exception, one amino acid, which is proline. Proline, as we all know, is only one amino acid which does not have a free NH2 group. It is rather a imine or secondary amine amino acid. Okay. So, the structure of proline is this. This is the structure of proline, as you can see here. So, it is a cyclic amino acid which has a secondary amine group. It does not have a free NH2 group like other amino acids. Okay. So, the proline, when it reacts with ninhydrin, so this kind of mechanism happens. Okay. So, this NH, it attacks on this. So, this ninhydrin can stay as this form also, this triple carbonyl group or this kind of functionality. Actually, the actual structure of ninhydrin is this, but when there is a moisture or in a solution phase, ninhydrin stays as this form. Okay. So, it does not matter if it stays as this form or this form. So, what will happen, this nitrogen lone pair will attack on this carbonyl carbon and we will have this kind of intermediate stage. Okay. And when this stage is formed, what will happen, like there is a elimination of water, and this kind of functionality generates, which takes part in the resonance, and due to resonance in this part, the brownish yellow color is formed. Okay. So, from ninhydrin test, I do not think you will be asked to draw the mechanism of the particular reaction, but if you can remember the mechanism, it is very good, which will help you in future. Okay. So, many times or in many examination I have seen like question for the ninhydrin mechanism has been asked. Okay. So, remembering the mechanism is very good, but if you cannot remember the mechanism, it is also there is no major problem, but just remember, like most of the amino acid irrespective of the R group. Okay. So, the color does not depend on the R group of the amino acid, but it does depend on the structure of the amino acid or free amine group. That is why proline only is the only amino acid which does not have a NH2 group free, and that is why it shows brownish yellow coloration, not the bluish purple coloration. Okay. So, this was your problem number 7. Now, I will move toward your problem number 8. Okay, we have somebody wants to join. So, very good, you all of you participated and answered this correctly. Okay. So, now we will move toward our next problem. So, problem number 8, it says that which of the following statement regarding prostaglandin is false. Number A, They are a class of steroid molecule. Number B, they are group of C15 carboxylic acids derived from arachidonic acid. Number C, prostaglandin varies depending on the geometries and position of the double bonds. Number D, they regulate the kidney function and also control inflammation. So, prostaglandins are a very important class of biomolecules, okay, and this question is regarding this prostaglandins. You have to identify which of the following statement is false. Just read the options very carefully. If you know the answer, you can write in the chat box. If you do not know, that is also fine. We will discuss about prostaglandins in detail. Take 1 or 2 minutes, and if you know the answer, write in the chat box. So, your options are: number A, they are a class of steroid molecule; number B, they are a group of C15 carboxylic acids derived from the arachidonic acid; number C, prostaglandin varies depending on the geometries and the position of the double bonds; number D, they regulate the kidney function and also control the inflammation. You have to identify which of the following statement is false. Okay, so we have number B. Okay, B is the most common answer. So, let me check what is the correct answer, then let us discuss about prostaglandins. So, very good. The false statement is number B. They are a group 15 C15 carboxylic acid derived from arachidonic acid. So, this is the prostaglandin. So, if you can see the structure, if you count the carbon, as you can see, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So, actually prostaglandins are a group of naturally occurring unsaturated hydroxy or hydroxyketo fatty acids. Von Euler, believing that the bioactive substance was produced by the prostate glands, coined the term prostaglandin in 1935. The prostaglandins are C20 carboxylic acid with a cyclopentane ring. The cyclopentane ring with two side chains containing a beta keto or an enone or hydroxyl group functionality. The side chains are unsaturated with 1, 2 or 3 double bonds, and a common feature all bioactive prostaglandin is a alpha hydroxyl group of C15, for example prostaglandin E1 and prostaglandin A2. Okay. So, at C15, if you count like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So, this is the C15 carbon. Okay, here a alpha hydroxyl group, it is very common feature for a bioactive prostaglandin. So, they actually derived from arachidonic acid, but they are not C15, they are actually C20 carboxylic acids. Okay. So, that is why number B is incorrect. Okay. So, very good, all of you, most of all of you have answered this question correctly. Now, I will move toward the next problem. Okay, here also we have a mathematics. It says that calculate the value of Pi of aspartic acid. Provided values are pK1 is 1.89, pK2 is 9.60, pK3 is 3.65, where pK1 is alpha carboxylic acid, pK2 is alpha NH3 plus, and pK3 is side chain residue. Just try to answer this question. I will show you in detail how the this question is solved with the structure of the amino acid particularly, and after that the problem number 10 is also like calculation for Pi, that I will give you some time for solving that question. I think if I show you how to solve this kind of question, you can easily solve the next one also. Okay, but if anybody wants to try right now, just take some time and calculate this question. Or I think I should show you how to calculate this question, and then I will just give you the next one. I think that will be better. So if you have any confusion, you can just check. Okay, we already are starting having the answers like number D, number C. Okay, let me check. Okay, so the correct answer is yes, it is number D. Very good. So let me show you how this kind of question is calculated. I mean the question is solved. See, this is the structure of your all protonated aspartic acid, okay, and this form stays in the lowest acid. So the pH is increasing from here to here, okay. So the pH of the solution is increasing in this side, okay. This is acidic, and this is basic side. So if I change the pH from acidic to basic, that's how the changes in the amino acid structure happens, okay. So in the lower pH, means in the acidic pH, all the groups are protonated, okay, all the groups are protonated. So the net charge is +1. Now as you can see, pK1 is 1.89, it is the pK1 of the alpha carboxylic acid. Means when we increase the pH and the pK of 1.89 is crossed, what will happen? Alpha carboxylic acid, means this group will be deprotonated, okay, like this. So since at first the net charge was +1, now the net charge is +1 -1 0, okay. Again I am increasing the pH. What will happen if when the pK of 3.65 is crossed? So pK 3.65 is the pK3, means the pK of side chain, means of this carboxylic acid group. When this is crossed, this also will stay as carboxylate group. So here what is the net charge? There are 2 -1, 1 +1, means the net charge is -1, okay. Again if I increase the pH and when the pK 9.60 is crossed, which is the pK2, means the alpha amine NH3 group's pK. Now when it is crossed, what will happen? This group will be deprotonated, means it will be become NH2. So the net charge will be -1 -1 -2. Now as I have mentioned, PI value will be the average of two pKs where the net charge will be 0. So between these two pK value, like this pK 1.89 and 3.6, in between these two the net charge of the amino acid is 0, means here it stays as a Zwitter ion. So what will be the PI value? It will be average of these two. So the PI value, it will be average of 1.89 and 3.65, means 2.77, okay. That's how you have to actually solve this kind of question, okay. In the previous example, it was a little bit difficult to understand, I think, but here I have just lucidly given you all the structures, so that so you can understand how this calculation is happening, okay. For this kind of question, as I always said, like you have to have a little bit of idea about the structure of amino acid. Like in the aspartic acid, there will be a side chain which will have a carboxylic acid group, and how it is protonated or deprotonated, okay. So this was your problem number 9, okay. So I have shown you how to solve the problem number 9, and I will now show you the problem number 10. When I will show you the problem number 10, I want all of you to try to answer the problem number 10. It was just similar as the problem number 9, okay. I will just give you 2 minutes, okay. I will keep my camera and my microphone off, but I want all of you, but I am not leaving the class, okay. I am here, but I want all of you to try to answer the problem number 10. After you try, I will show you, I will see the answers in the chat box, then I will show you how to solve it. It is just like the problem number 9, so there is a little bit of difference, okay. So let me show you first the problem, then I will just give you some time. So problem number 10, it says calculate the value of PI of lysine provided pK1 is 2.18, pK2 is 8.95, pK3 is 10.53, where pK1 is alpha carboxylic acid, pK2 is alpha NH2, NH3 plus, and pK3 is side chain residue. It is just like your problem number 9. So I want all of you to try to answer this question, okay. I will just keep my camera and microphone off for 2 minutes, but after 2 minutes when I will check the answer, I want all of you to try and write the answer in the chat box. Okay, I am not leaving, I am just keeping my microphone and camera off for 2 minutes. Okay, meanwhile after answering the question, you can take a break. Okay. Hello. So is my voice audible and is my video visible to you? I have just came back to see. I have just come back to see your answers. Yeah, okay, thank you very much. So I think there are few answers, right? So there are answers like B, number C, number D. Okay, it is good that all of you have tried to answer it. Okay, so again it does not matter if it is correct or wrong. So let me check the answers. We have number C, number B, D, number C, number B. Okay, so number B and number C I think is the most common or most frequent answers. So okay, let us check what is the correct answer of this question. Okay, so number B and number D, these two were, I think, no, number B or number C were the most frequent answers, right? So let me check. So very good, number C is the correct answer. So whoever has answered number C, you have understood the problem, how to do it. So whoever have missed the answer, so don't worry, I will show you how it is done. Okay, what is the difference between lysine and aspartic acid? So lysine is a basic amino acid. Okay, aspartic acid, it was a acidic amino acid. So again I have told you, like you have to have some insight about the structural features about the amino acids. Okay, so as you can see here, this is the acidic, in the most acidic form, the net charge of the lysine is +2. When the pK of 2.18 it is crossed, what will happen? It will have the net charge of +1 because the carboxylic acid group will be deprotonated. When the pK of 8.95 is crossed, what will happen? 8.95 is the pK2. pK2 means the alpha amine group, means it will be converted to the NH2 group. Okay, and in the pK3 it will be stays at -1. So here we have to average the second two values, means the pK this value and this value. Okay, so okay, there is, I think I have just put the wrong answer here. Okay, one second, I have just missed it. It will be 9.74. Okay, So it will be the correct answer. So one thing about this kind of questions, so I think you have understood how the question is solved, right? How the calculation part is done. So if you have any doubt, so don't worry, if you read this thing more carefully, okay, if you just practice by yourself, just in internet you will get about the what is the pK values of the amino acids. So if you just take these values and try to calculate by yourself, you will easily understand how it is happening, okay. And if you have any doubt, you can just tell me next day I will also point out about the what is the correct answer. So one easy way to I think remember this particular problem is there, okay. So the easiest way to remember how to calculate the pi values is, for the neutral amino acid there are no need to remember anything, because for the neutral amino acid there are only 2 pKa value, you have to average the 2 of them, okay. For the acidic amino acid, what you have to do, just I will show you the last question, yes, this one. For the acidic amino acid, if the 3 pKa values are given like this, 1.89, 9.60, 3.65, so you have to average out the lowest 2 values, okay. So the lowest lower 2 values are 1.89 and 3.65, you have to average these two for having the pi, okay. And for the basic amino acid like lysine, what you have to do, you have to average the greater 2 values, means 8.95 and your 10.53. So this is the shortcut for remembering this kind of question, but I actually want all of you to understand why it is so, okay. So I think if you just practice and look at the structure carefully, you will understand how it is calculated, okay. Just always remember at the pK, 2 pK values in between, the pK value this and this, in between the net charge of the amino acid is 0. So we have to average out these two, okay. This is the easiest way. So I think all these 10 questions were related to most of the your week 1 course content. Now I will move toward the your week 2 course content, and next 10 question will be from your week 2 course content, okay. Now I will move toward the problem number 11 quickly. So problem number 11, it says, which of the following derivative is formed in the Edman degradation of the polypeptide chain? Your options are number A, DNP derivative, number B, PTH derivative, number C, DCC derivative, and number D, DNS derivative. Edman degradation of polypeptide chain is a very important method where the protein sequence or polypeptide sequence we can identify, okay. It is a very important protein degradation method. There are also other method like Sanger's method and all things. So just try to answer what is the derivative which is formed if we use Edman reagent on a particular polypeptide chain. Number A is DNP derivative, number B is PTH derivative, number C is DCC derivative, and number D is DNS derivative. Is there any answer? Okay, once more, I think you are confused about the PI calculation part, right? So I will actually let me finish all the questions, and then at last I will again show you the PI calculation part, okay. I think some of you will have confusion regarding the PI calculation, but don't worry, I will just repeat it at the end of the class. Let me finish all the question at first, then I will just repeat again the PI calculation parts, okay. Will it be fine if I repeat it at last? Okay, I have again one answer for 11. Okay, let me finish all the question, then I will again discuss the PI calculation. I know many of you will have the problem understanding it, but don't worry, I will remember. So 11, we have already one answer which is say number B, PTH derivative. Now let us see what is the Edman degradation and what is the name of the derivative. The correct answer is number B, it is the PTH derivative. Now PTH, it stands for, let me show you. Okay, so PTH, it stands for phenyl thiohydantoin, okay. So this is the structure of the hydantoin. This particular group, it is known as hydantoin. So there are 2 NH group, 2 carbonyl group, and there is a 5-member ring. If one carbonyl oxygen is replaced by sulfur, it is called the thiohydantoin. Okay. So as this is the phenyl isocyanate, this particular reagent is called phenyl isocyanate, which is used for the Edman degradation of the protein or polypeptide. So let me show you how this is the mechanism of the particular. This is the polypeptide chain, this is your peptide linkage, and there is a free NH2. All of you know that a polypeptide chain has a NH2 group free at one side and a carboxylic group is free at one side. Where the NH2 group is free, it is called the N terminus end, and when the carboxylic acid group is free, it is called the C terminus end. Okay. So what will happen, this N terminus free NH2 group, it will use its lone pair to attack this carbon of this phenyl isocyanate. Okay. Now what will happen, there will be a resonance, and at pH 8 this kind of reaction will happen. Okay. And after all this mechanism, all this ring forming and ring closing, this will be formed, this phenyl thiohydantoin derivative is formed. So what will happen, let me tell you. So say there is a polypeptide chain like amino acid A, B, C, D and E. Let us say there is this 5 amino acids in a polypeptide chain. Okay. This A is the N terminus end, means it will have a NH2 group free, and this E is the C terminus end, means it will have a carboxylic acid group free. Now when we will add this phenyl isocyanate, okay, this is the Edman reagent. When we will add this Edman reagent, this free NH2 group of the N terminus N will react with this Edman reagent, and it will eventually cleave the polypeptide chain here. Okay. And if the cleavage happens, we will have this PTH derivative of this, okay, it is P, this PTH derivative of this N terminal amino acid, means with A. So this is here, with, as you can see, the N terminus have this. So here, from here the cleavage happens. Okay. And we will have this group, it will be separated, and the N terminus amino acid, it will react with phenyl isocyanate and will make a PTH derivative of a amino acid. So by looking at the structure of this PTH derivative, we can understand what was the N terminus amino acid of this particular polypeptide chain. That is how we understand. See, I give you a polypeptide chain, and I tell you what is the sequence of that polypeptide chain, means which amino acid is in the N terminus, after that which amino acid is there, and after that what is the amino acid. What we will do, what you have to do is, you have to add Edman reagent, the PTH derivative will form, and by looking at the structure of this particular side chain, this R side chain, you will know what is the particular amino acid was present in the N terminus, and again and the subsequent N terminuses. Okay. So like, say for example, if the R group is CH3 methyl, then the amino acid is alanine. Okay. That is how the Edman degradation happens. So Edman degradation is the one method for protein, very important method for protein sequencing. Okay. And the derivative which is formed is called the PTH derivative. Okay. Now I think it is clear. Just you have to read about this Edman degradation, how it happens. So yeah, 11B was the correct answer. Very good. So now I will move toward the next problem. So the problem number 12, it says that which of the following statements is false? Please read all the options carefully, but try to answer this question. It is not so much difficult, but read the options carefully. The enzymes are called artificial scissors for peptide bond cleavage. Number B, trypsin is highly selective for peptide bond cleavage for basic amino acids except arginine. Number C, peptidases can be called proteases. Number D, an enzyme with broad specificity is not suitable for peptide degradation. You have to identify which of the following statement is false. Enzymes are called artificial scissors for the peptide bond cleavage. Trypsin is highly selective for peptide bond cleavage for basic amino acid except arginine. Peptidases can be called proteases. An enzyme with broad specificity is not suitable for peptide degradation. Try to answer this question in the chat box. Which of the following you think is the false? So, is there any answer? Question number 12. Okay, 12. So, there are 12B, B, A, B, C. So, we have multiple answers, right? Okay, nothing to worry about it. So, let me show you what is the answer. So, the correct answer means the false statement is number B. Trypsin is highly selective peptide bond cleavage for basic amino acids except arginine. Actually, so let me show you. So, actually pepsin, let first focus on this part. So, actually trypsin actually is selective for peptide bond cleavage for basic amino acids, but not except for arginine. The exception is there for histidine. So, trypsin, so wherever actually trypsin, what trypsin does, trypsin cleaves at the C terminus end of a basic amino acid. Okay. So, remember trypsin, it actually cleaves at the C terminus end, of a basic amino acid. Like if you can see, there is this polypeptide chain, it is the basic amino acid is here and it is the C terminus end where the trypsin cleaves, and trypsin actually cleaves only lysine and arginine, not histidine. Okay. So, this will not be arginine, this will be histidine. If there was histidine, it would have correct. But why histidine? Because histidine is the basic amino acid, but the basicity of histidine is less compared to the arginine and the lysine. Okay. All the three options are correct. Enzymes are called artificial scissors for the peptide bond cleavage. Enzyme with broad specificity is not suitable. Okay. And peptidases can be called proteases. Now, I want to discuss about this peptidases and proteases. So, proteases and peptidases, what are these? Proteases or peptidases are enzymes that catalyze the break of down the peptide chain in the protein and peptides. Proteolysis is the process of the controlled or uncontrolled degradation of proteins or peptide. So, what is the difference between the protease and peptidase? An enzyme which breaks down the protein and peptides is called the protease. Enzyme which breaks down the peptide and amino acids, break down peptides into amino acids is called the peptidase. So, proteases are a hydrolytic enzyme that hydrolyzes the peptide bond, and peptidase is only a part of proteases, means all peptidases can be called proteases, but not all proteases are called peptidases. Okay. So, you have to remember this thing. Proteases is rather a bigger class of enzymes, peptidases is just a little bit part of the proteases. So, you can say like peptidases is a kind of protease, but not all the protease is peptidase, because peptidase enzymes, they can break down the proteins in the polypeptide chains. Okay. But peptidase can only break down polypeptide into amino acids. Okay. So, that is the difference. So, there are two types of proteases, endopeptidase and exopeptidase. Peptidases are actually exopeptidase. Okay. They hydrolyze internal peptide bond, they hydrolyze peptide bonds at the end, prefer intact protein, prefer small peptides, result in oligopeptides, result in single amino acids or dipeptide. Example, pepsin, trypsin, chymotrypsin, papain, elastase. Okay. These are the proteases. Example, aminopeptidases, carboxypeptidase A. So, these are the example of the peptidases. So, actually peptidases are more broader class of enzyme and less broader class of enzyme, and proteases are more a bigger class of the enzymes. Okay. So, this was the difference between peptidases and proteases. Okay. So, now it was your problem number 12. Now, I will move toward the problem number 13. So, it says that there is a dash, you have to fill in the blanks. Okay. So dash is specific for breaking the peptide bond associated with amino acid methionine. You have to identify the particular reagent which is specific for breaking the peptide bond associated with the amino acid methionine. Your options are number A cyanogen bromide, number B methyl iodide, number C cyanogen iodide, number D trypsin. Which of the following reagent is specific for breaking the peptide bond associated with amino acid methionine? Try to answer this question in the chat box. Is it cyanogen bromide or methyl iodide or cyanogen iodide or trypsin? So let me check the chat box. Okay, number A, number A, number A. So the most answers are for number A. Okay, let us show what is the correct answer. So very good. The correct answer is number A, cyanogen bromide. Now, why cyanogen bromide is specific for the peptide bond associated with amino acid methionine cleavage. Okay, this is the structure of methionine. So methionine is a very important essential amino acid which has a sulfur. Okay, so it is a cysteine methionine. These are the sulfur containing amino acids. Okay. So this is the this is the particular mechanism for the cyanogen bromide cleavage for the methionine. So as you can see, this is a cyanogen bromide. Okay, it is CNBr. Okay. So now as you can see, this is the polypeptide chain. It has a methionine side chain here. Okay, the SME3, sorry, the SCH3 is present here in the side chain of the methionine. So if there is a cyanogen bromide, so what will happen? This sulfur has a lone pair. Okay. Now this lone pair of sulfur will attack this carbon of the cyanide group and this bromine will be cleaved. So we will have this kind of moiety. Okay. The sulfur will be positively charged, there will be a negatively charged bromine and this kind of brom. So when there is this kind of moiety, what will happen? This amino acid, this group actually bond, it will actually rotate. Okay. If this bond rotate, as you can see, the carbonyl group comes here and nitrogen comes there, and there will be a resonance. So this, as we all know, peptide bond, the amine group can take part in resonance. So this nitrogen lone pair will be donated here. Okay, the nitrogen lone pair will be donated here on the nitrogen carbon nitrogen bond, and this double bond will put a negative charge on the oxygen, and this negative charge will attack here, and this ring carbon and this group will be broken. Okay, so we will have this compound, this methyl sulfur and cyanide, and we will have a bromide. Okay, and here nitrogen has a plus sign and this minus, and we will have this kind of structure. Okay, this kind of peptide fragment. Now if there is a water, and if water is added, hydrolysis will happen, and when the hydrolysis will happen, here it will be broken. Okay, if it breaks here, if it will have a homoserine lactone unit. This particular unit is called the homoserine lactone unit. Okay, and it is the N terminal fragment and it is the C terminal fragment. Okay, so as you can see, this particular cyanogen bromide cleaves a polypeptide chain at the C terminus of the whenever there is a methionine. Okay, from here it will cleave the amino acid. So this is a particular for only methionine, it will not react with others. So yeah, number A was the correct answer. Okay, so very good. So now I will move toward the next problem. Okay, sorry. Okay, so it was your now problem number 13. So now problem number 14, it says which of the following amino acid restricts the action of chymotrypsin? Your options are number A alanine, number B serine, number C proline, and number D methionine. Chymotrypsin is another kind of protease which actually particular for breaking the polypeptide chain as a particular sites, but there is one amino acid which restricts the action of chymotrypsin, okay, and you have to identify which of the following is the correct option. Number A alanine, number B serine, number C proline, number D methionine. So, which of the following amino acid restricts the action of chymotrypsin? Try to answer it. Is there any answer? Let me check. Okay, it's all right if you don't know the answer, okay, because we don't have any marks for today's session. So, it is okay if you know the answer, you can write in the chat box. If you don't know, it's also fine. So, let me check. I think it starts from here. Number A, C, B. So, we have multiple answers for it. So, let me check what is the correct answer. So, the correct answer is number C, proline. So, let us discuss what is the chymotrypsin. So, chymotrypsin is another protease like trypsin. Chymotrypsin as in previous slide we have said, like trypsin is a particular protease which breaks the C terminus end of a basic amino acid of lysine and arginine. So, what does chymotrypsin do? It actually breaks the polypeptide chain at the C terminus of the of a aromatic amino acid, okay. Means if a polypeptide chain has a aromatic amino acid like phenylalanine, tryptophan and tyrosine, okay, then what will happen? It will just cleave it, provided so it will cleave it here at the C terminus end of the particular if R here, R is the phenylalanine, tryptophan or tyrosine, then it will just cleave at the C terminus end of the particular polypeptide chain of the particular amino acid. But if the next amino acid of the aromatic amino acid is proline, then the cleavage will not happen, okay. So, let me show you like here. Chymotrypsin breaks the peptide bond involving the aromatic amino acid at the carboxylic end. About chymotrypsin, one thing you have to remember is that the adjacent amino acid, there is one restriction. If the amino acid happens to be proline, then hydrolysis cannot take place. So, the next amino acid which is connected to the amino acid happens to be proline, then hydrolysis cannot take place. So, let me show you one example. See, you have a polypeptide chain like there is alanine, then you have tyrosine, then you have histidine, and then you have glycine. If you have this particular polypeptide chain, among these four, tyrosine is only the aromatic amino acid, okay. So, if you add chymotrypsin, what will happen? It will cleave at the C terminus end, it is the N terminus, always remember, left hand side it is the N terminus and right hand side it is the C terminus. So, it cleaves at the C terminus end of the aromatic amino acid, means it will cleave here, okay. But if you have a polypeptide chain like this, like we have alanine, then I have tyrosine, then I have proline, and then I have glycine. So, what will happen? If you add chymotrypsin, it will not act on this particular polypeptide chain. Why? Because at the adjacent amino acid of this aromatic amino acid is proline, okay. So, that is the restriction of the chymotrypsin, okay. So, remember these two things. Chymotrypsin is particular for peptide bond involving the aromatic amino acid, but one restriction is there, like if next amino acid is happens to be proline, then the hydrolysis cannot take place. Okay. So, this was about the chymotrypsin, how where it breaks and what is the particular restriction regarding this chymotrypsin application. Okay. Now, I think you have understood. Whoever didn't know the answer, now you will know, now you know the answer, okay, regarding this. So, now I will move toward the next problem. Okay, so here is an application based question of the particular chymotrypsin. So, if chymotrypsin is used on a polypeptide chain of this methionine, tyrosine, leucine, tryptophan and phenylalanine serine. Okay, now how many fragments will be formed? How many fragments will be formed if this is the polypeptide chain? If you add chymotrypsin in this polypeptide chain, how many fragments are formed? Okay, this is the polypeptide chain. Your options are number A 4, number B 3, number C 2 and number D 5. Look at the structure very carefully. If you have pen or paper, just write the sequence in your pen and paper. Remember what I have just said in the previous slide and try to find out how many fragments will be there if chymotrypsin is added in this polypeptide chain. So, are there any answers? Let me check. Number B, number B, number B, number B. I think everybody is saying number B. There is a one number A, I think. Otherwise, everybody is saying it is number B. So, I have told you, like, look at the structure very carefully. Okay, let me show you. Nobody. So, remember there are 3 aromatic amino acids: tyrosine, tryptophan and phenylalanine. Correct answer will be number A. I think there was one number A in the chat box. Okay. So, 4 fragments will be formed. Why 4 fragments will be formed? So, C. Okay, sorry, there is my one mistake, small. There should be one glycine. Even if there is a one glycine less here, but it's fine. Just 1 second. So, if you see here, here I just missed one amino acid from this question, but still there will be 4 fragments. How I will show you? If you can see, it will break the C terminus of the aromatic amino acid, like. So, first aromatic amino acid is tyrosine. So, here it will be fragmented. So, your first fragment will be what? Your first fragment will be methionine and tyrosine. Okay. So, then where it will cleave at here, at the side of the tryptophan. So, what is the fragment? The fragment will be leucine and the fragment will be tryptophan. Okay. Now, phenylalanine is also aromatic amino acid, means here also it will be cleaved. Okay. So, we will have 2 more fragments. One is only solely phenylalanine and one is solely serine. Okay. So, I had just made a mistake, like from this original example I just missed here. So, I will just clear it here. Okay. So, there will be after tryptophan there will be one as per one this GLN. Okay. Still, if does not matter if the group was there or not, still the answer will be 4. 4 fragments will be there. First, chymotrypsin digestion will happen here. We will have this original N terminus and new C terminal here. Then we will have a new N terminal here and new C terminal here, and that's how the subsequent breakage will form. Okay. So, this is the correct answer, the number 4. There will be 4 fragments. Okay. Even if the asparagine residue was not here, still there will be 4 fragment. Okay. So that's how chymotrypsin works. Now I will move toward the next problem. Now problem number 16, it says that which of the following statements regarding pepsin is true. Number A, it was discovered in 1876 by William Kunde, and number B, its acting site is duodenum. Number C, it cleaves at the peptide bonds at C terminal end. Number D, it is an exopeptidase. It will be an exopeptidase. I think it is an exopeptidase. Okay, there is no space. I will just modify it later. So the options are: number A, it was discovered by 1896 by William Kunhe. Number B, its acting site is duodenum. Number C, it cleaves the peptide bonds at C terminal end. And number D, it is an exopeptidase. Okay, which of the following statement is true? Try to answer this question. Which of the following you think is the true statement regarding the pepsin? Let me check if there is any answer correct or wrong. Number C, number C, number C. So most of the answers are number C. Okay, so let me check. Okay, we have one number D and one number A, and most of the cases it is number C. Okay, let me check what is the correct answer. So correct answer is number D. It is true. It is an exopeptidase. One second, let me just correct it. Okay, sorry, very sorry, it will be false actually. Very sorry, it's my mistake. It will be false. Okay, because number D is false, because it is a endopeptidase, it is not an exopeptidase. Okay, so very sorry, this was my mistake. Okay, so the false statement you have to identify. The first three statements, these are true. It was discovered by William Kunhe in 1876. Its active site is duodenum, and it cleaves the peptide bonds at C terminal end. These three statements are true. It is an exopeptidase. This statement is false. Okay, so as you can see here, pepsin is an endopeptidase that breaks down the proteins into smaller peptides, that is protease. It is a kind of protease. It is produced in stomach and one main digestive enzymes in the digestive system of humans and many other animals, which helps to digest proteins in the food. So what is the difference between the endopeptidase and exopeptidase? Endopeptidase act in the interior of the protein, but exopeptidase, they act on the periphery of the protein molecule. So protein is a very big macromolecule. Okay, so some enzymes, some peptidase, they actually break it from the interior, which are called the endopeptidase, and some works on the exterior of the protein molecule, which are called the exopeptidase. So endopeptidase, they cleaves the internal peptide bonds. Exopeptidase, they cleaves the terminal peptide bonds. This end product is smaller peptides. Its end peptide is free amine or amino acids and dipeptides like pepsin, renin, trypsin, chymotrypsin, elastase. These are all the endopeptidase, and carboxypeptidase, aminopeptidase, these are the exopeptidase. So for remembering it very easily, like say there is a polypeptide chain like A, then there is a B, then C, D, E and F. See, these is a polypeptide chain and these all are 6 amino acid. Endopeptidase, it will break in between, okay, and exopeptidase, it will break on the terminus. This is the difference. So pepsin is a endopeptidase, that's why option number D is false. Okay, it is the incorrect. So the question was wrong, it was my fault. But you remember, like pepsin is a endopeptidase. Okay, so now I will move toward the next problem. We have few more problems left in today's session. After that, I will just ask you what is your problem, and you can just tell me which part you did not understand or I need to repeat it. Okay. Okay, So next problem is, which of the following is not a phosphorus based coupling agent? Okay, your options are number A PIBOB, number B DCC, number C HBTU and number D HATU. So all of this reagent, let me tell you, all of these 4 reagents are peptide bond forming reagent. I have said you and previously, like peptide bond forming reagents are there, which actually help us to form the peptide bond. So formation of a peptide bond is actually not very easy, because there is a acidic group and there is a amine group, but the formation of peptide bond is not easy. It cannot happen without any additive or without any coupling reagent, because the activation energy for the reaction is very high. Okay, so we will have to rather need a particular coupling agent which can activate the carboxylic acid or amine group and make the peptide bond formation more easier. So as most of you have answered already, the correct answer is DCC. DCC is not a phosphorus based coupling agent. Now I will show you the structure of all the reagents. Okay, so PIBOB, this is the structure of PIBOB. This is the structure of DCC. This is the structure of HBTU and this is the structure of HATU. So all of these 4 reagents are the peptide bond forming reagents, and these are this PIBOB, HBTU and HATU, these are the phosphorus based coupling reagent, because as you can see here there is a phosphorus atom. Okay, here also and here also. So there are phosphorus atoms, but only DCC is one such reagent which does not contain a phosphorus group, but still DCC is the most frequently used peptide bond forming reagent. Okay, so there is a particular reaction. So when there is a carboxylic acid group, and as you can see there is a in the peptide bond formation there is a carboxylic acid group, right, and there is a amine group. There is a amine group and both of these group reacts and there is a peptide bond formation, means C double bond O and then NH. So there is a elimination of water molecule. Sorry, there is a elimination of water molecule minus H2O. So what DCC does, DCC helps this elimination of water molecule, and DCC is converted into DHU, which is dihydroxyurea. Okay, DCC converted into DHU by taking up this water and peptide bond is formed. So DCC is only for non-phosphorus based peptide bond forming coupling reagent. Okay. So now I will move toward the next problem. Okay, again read this question very carefully. So Sanger's reagent, so you have to identify like which is the following statement regarding Sanger's method is false. Number A, this method is used to know the amino acid from the C terminal end. Number B, the reagent used in Sanger's method is 2,4-dinitrofluorobenzene. Number C, Sanger's method can easily distinguish between a cyclic and an acyclic peptide. Number D, amino acids are identified by the help of HPLC in this method. Like in question number 11, I think we discussed about the Edman reagent. Edman reagent was a particular reagent which helped us to know the what is the polypeptide sequence by forming the PTH derivative, right. Sanger's method and Sanger's reagent is also a very popular and I think most oldest method for the peptide bonds, peptide polypeptide chain sequencing. Now here you have to identify which is the statement is false. Read the statements carefully and try to answer this question. After your trial, I will just show you the answer and I will discuss the Sanger's method. Okay, so the answer is number 17th, number D, number A. So we have I think number D and number A, the most frequent answers for this question, right. Okay, let me check what is the correct answer regarding the Sanger's method. So, the correct answer is number A, means number A statement is false regarding the Sanger's method. This method is used to know amino acid from C terminus end. This statement is false because like Edman reagent, Sanger's reagent is also used for the N terminus end, not the C terminus end. Okay, so this one is false. So, let us see what is the Sanger's method and how this thing happens. Frederick Sanger had demonstrated a method to determine the amino acid residue located on the N-terminal end of a polypeptide chain by using the reagent called fluorodinitrobenzene or 2,4-dinitrofluorobenzene. Sanger showed for the first time that amino acids are covalently together by alpha amino and alpha carboxyl group. He suggested stepwise release and identification of amino acids starting from N-terminal. He used a reagent called fluorodinitrobenzene, which is commonly called Sanger's reagent. This FDNB reacts with free NH2 group of N terminus. Upon hydrolysis, yellow colored DNP derivative is formed of the N amino acid site is produced. So, what is the mechanism? So, let us see, this is the Sanger's reagent, which is 2,4-dinitrofluorobenzene, okay, or DFN. So, it can be abbreviated as any way, but you have to just remember the structure. Okay, the structure is like this. There are 1, 2, 3, 4. The 4 position, this is 1 position, 2, 3, 4. Okay, so there are 2 and 4 position, there are 2 nitro groups, and at the 1 position there is a fluorine, and this is it is a polypeptide chain where there is a free NH2 group here present. So, how the reaction happens? Actually the mechanism goes like this. There is a nitrogen's lone pair of the N-terminus nitrogen free NH2 group. It actually attacks this ipso carbon, and fluorine actually get released by a substitution elimination method, and we have this DNP polypeptide chain. Okay. Upon hydrolysis, N-terminal amino acid has a chromophore attached which can be separated and identified. And if this is the DNP polypeptide chain, and if we hydrolyze it, what will happen? After hydrolysis, there it will be released. Okay, this particular thing it will be released, and it is called the DNP derivative of the particular amino acid. Okay. So, Sanger method, like Edman method, is a very popular and most I think used method for the polypeptide chain sequence determination. Okay. Now, problem number 18, it says that which of the following is the correct match. So, it is a particular there are various reagent. Okay. So, you have to identify. So, here as you can see, there is a ester group and there is a aldehyde group. You have to identify, and the reagent 1 is used, only aldehyde group is reduced. There is a ester, there is a aldehyde. When we are using reagent number 2, both of the groups getting reduced, and if there is a carboxylic acid, it is carboxylic acid, it is reduced to the aldehyde. So, there are reagent 1, 2 and 3, you have to identify which is the particular set of the reagents. Your options are number A, 1 is dibyl H, and 2 is NaBH4, 3 is lithium aluminum hydrate. Number B is this the permutation combination of these 3 reagents. You have to identify correct reagent for a particular set of reaction. Since you are dealing with amino acids and the groups are related to the acids and ester and aldehyde, you have to know what are the particular reagent which we can use for a particular group for the reducing of the particular group. So, is there any answer for this question? Let me check. We have few minutes left for the class, so let me check. Okay, number I think these, yeah, always I will share all these notes. Okay, so don't worry about it. So, I think these are the answers, number D and number C. So, B, D and C are the common answers. So, let me check what is the correct answer. This question is more about related to the organic chemistry. So, the correct answer is number D. 1 is the NaBH4. So, if you add NaBH4 here, it will only reduce the aldehyde group, but it will not touch the ester group. Number 2 is lithium aluminum hydrate, which is rather more strong reducing agent, which reduces both the ester group and the aldehyde group, and Debel is used particularly for the reduction of the acid to aldehyde. Okay. So for this particular thing I will show you one chart. So this is a particular chart which is very carbonyl reduction using hydride reducing agent. Okay. So this is the chart, how it works. Like we have these are the carbonyl containing groups. Imine is not carbonyl, but imine carbon is more electrophilic. It is imine is more or less like carbonyl carbon. Okay. So for the imine group, it is very much reactive, and as you go from imine group to carboxylic acid group, the reactivity or the electrophilicity of this carbonyl carbon reduces. Okay. So these are the reducing agents. Okay, and this is the reduction products. What will happen? Okay. So this green means reduced easily, now orange means reduced slowly, and red means not usually reduced. Okay. So if you add sodium borohydrate, as you can see, it can reduce the aldehyde, it can reduce the ketone, but it cannot reduce the ester, or it can reduce the ester, but it is very slowly. If you use lithium aluminum hydrate, most of the things get reduced easily. Okay. Debel can be used carboxylic acid, and it is via acetyl chloride. Okay. And this ester can be reduced through this via Debel. Okay. So this chart, I think if you remember this chart, it will be very easier for you to answer this kind of question. Now I will move toward the next question. So question number 19, it says that which of the following statement regarding the FMOC protection deprotection is false. Okay. FMOC stands for 9-fluoronyl methoxycarbonyl chloride. Number B, in case of deprotection, aqueous piperidine is used. Number C, inorganic bases can also be used for deprotection of FMOC protected amines. And number D, extent of protection deprotection can be quantified by the help of HPLC in this method. So FMOC is a particular very important amine protecting reagent. Okay. So there are many reagents which can protect the amine group like TBOC, there are FMOC. Okay. So FMOC is particularly very important because it is used for a very interesting method of solid phase of peptide synthesis. Why it is used, I will discuss in the last question of today's session. But before that, just try to answer this question: which of the following statement regarding FMOC protection is false? Number A, FMOC stands for 9-fluoronyl methoxycarbonyl chloride. Number B, in case of deprotection, aqueous piperidine is used. Number C, inorganic bases can also be used for the deprotection of FMOC protected amines. And number D, the extent of protection deprotected can be quantified with the help of HPLC. Let me check if there is any answer regarding the question number 19. Okay, 19, number C. Number C, number D. I think A, B, C, D, 4 options are given here in the chat box. So let me check which is the correct answer, rather which is the false statement regarding the FMOC protection. So the false statement is number C. Inorganic bases can be used for deprotection of FMOC protected amines. It is false. Inorganic base cannot be used. Only aqueous piperidine is used for the deprotection. This is the FMOC Cl. Okay. The FMOC this is 9-fluoronyl methoxycarbonyl chloride. Okay. This is the mechanism of the FMOC protection. As you can see, this is the FMOC. Okay. And there is a this is hydrogen bonded with a water. So whenever there is a amine or free N terminus, free NH2 group of the N terminus of a polypeptide chain, it reacts with this particular carbonyl carbon of this acid chloride of the FMOC Cl. Okay, and this kind of concerted mechanism happen, and this derivative is formed with the nitrogen. How the deprotection happens? That's how the free NH2 group can be protected with this FMOC group. Okay, this is the free. There was a free NH2 group here, which is now protected. It will be written as like this. It will be written as FMOC, then NH, and then R. So it is the full FMOC group which is protects this free NH2 group. And for the deprotection, this is the piperidine. Okay, this aqueous piperidine is added here. So, what will happen, this will take up the hydrogen from this position. Okay, there is a hydrogen from this position, it will be taken by this aqueous piperidine, and then this bond will be cleaved. Okay, and concerted cleavage of the liberation of carbon dioxide and this group, the NH2 group is liberated. Okay. So, aqueous piperidine is the only reagent that can be used for the reprotection of FMOC, inorganic base cannot, that is why this statement was false. Okay. So, now the last question of today's session. Okay, so which of the following statements regarding Merrifield resin is true? Number A, it is a solution phase peptide synthesis. Number B, it cannot be used to synthesize large size peptide. Number C, here a polymer bead is used which is insoluble in the solvent which is used to solubilize the reagent. And number D, here T-Bock protection of amine group is more significant than the FMOC protection. Regarding Merrifield resin, you have to identify which of the following statement is true. Is it number A or number B, number C or number D? Read the options carefully and then write in the chat box which of the following you think is the correct answer. Number A, it is a solution phase peptide synthesis. Number B, it cannot be used for synthesize large size peptides. Number C, here a polymer bead is used which is insoluble in solvent which is used to solubilize the reagent. And number D, here T-Bock protection of amine is more significant than the FMOC protection. Let me check if somebody has answered this question or not. Number 20. Number D, number C, number C. Okay, so I think number C, and we have few number C and one number D. So let us check what is the true statement regarding the Merrifield resin. So correct answer is yes, number C. Here a polymer bead is used which is insoluble in solvent which is used to solubilize the reagent. Now what is a Merrifield resin? This is the Merrifield resin. It is chloromethylated polystyrene. It is a polymer bed. Okay. So basically Merrifield resin is used for solid phase peptide synthesis. So in solid phase synthesis, the starting material is bonded to an inert solid support. Reactants are added in solution. Reaction occurs in the interface between the solid and the solution. Because starting material is bonded with the solid, any product formed from the starting material remains bonded as well. Purification involves simply washing the byproduct from the solid support. So, as what happens in the solid phase synthesis, actually there is a polymer resin bed when there is this kind of polymer groups, okay, and we have this amino acids. This amino acids come and they react with this free chloromethylated end of this reagent. So let me show you how this reaction happen. So if there is a amine group, there is a carbon and there is a carboxylic acid group for the amino acid, and there is a R, okay, and there is a H. Let us see, this is the amino acid. So what will happen, this polymer bed, a solution of the reagent is added. In this solution free amino acids are there. So if there is a amino acid like here, it will attack on this position and it will move here. So that's how this NH2 group will be attached with this resin bed, okay. And after the attachment of a particular amino acid, when I add second amino acid, it will act with the free carboxylic acid end with this first amino acid, and that's how upon there is a resin bed, okay, this is a resin bed, let me say, and there is a chloro, this group is there, okay, and one by one amino acids come here and attached, okay, and there is a like this kind of a polypeptide chain grows. And what will happen after some after the time, what will happen, this will be easily detached from this group by using the particular reagents, and the byproducts will be washed off from this particular resin bed. Now here FMOC protection is more important for the NH2 group. Why FMOC protection is more important? Because if you deprotect FMOC, it generates methylene fluorine, which is a very fluorescent material. So seeing the fluorescence, the extent of fluorescence, you can calculate how much FMOC group has been deprotected. So we can know that how much the polypeptide incorporation is happens, okay. So as I in the previous slide I also have shown you, this is the methylene fluorine, it is a fluorescence compound, okay. By looking at this compound, the fluorescence, by checking fluorescence you understand what is the extent of the deprotection, and it helps to understand what is the particular flow of the synthesis, polypeptide chain synthesis. Okay. So, this was your last question. Okay. So, today up to this we have today's slide. Now, I think somebody has requested to repeat one thing. So, can you can take sense, you all of you tell me what is the part you want me to repeat. Is there anything which you want me to repeat? Is there anything which you did not understand? So, basically today we discussed more about amino acids, the isoelectric points, the peptides, the methods of peptide sequencing, the solid phase synthesis, and all of these were your week 1 and week 2 course content. Okay. Since your week 2 is live right now, so I completed this week 1 and week 2. In the next class, in the next Tuesday, we will discuss the week 3 courses only. Okay. The chapters and the part portions are included in week 3. We will discuss in the next Tuesday. Every Tuesday, yeah, always I will show this, I will share this note. Okay. So, what I will suggest, I will share this notes, okay, this PPT, this slide, and today's lecture video also, and I am sharing my email ID with you in the chat box. Okay. Wait a minute. Thank you so much that I could help you with this course, and once again .in. So, this is my email ID. Okay. So, if you have any doubt, any query, if you want to know anything about the session or about the course, about the classes, you can just drop me an email. I have just shared it in the chat box. Just note it down, and if you have any problem, you just drop an email to me before next class. I will just answer your query through the email, and once I share today's PPT and this lecture video with you in the NPTEL website, yes, any book, I will suggest the books in the next class. Okay. So, there are very good books about the medicinal chemistry and organic chemistry also, which I will suggest you in the next class. In the next class I will give you a list of books before starting the session, which you can follow for your this course. Okay. It will help you understanding the things more better, and I think I could help you in today's session. If you have any suggestion regarding the session, if you have any suggestion how to improve the session, please let me know. Okay. That will be yeah, my email, I will again share it. You can just contact me through this email, or you can just tell your query in the NPTEL website also. There is a portal given. So, there you can just write the query. So, every Tuesday we will have this kind of class from 8 p.m. to 6 to 8 p.m. I request all of you to join. Please join. Okay. At every day, please join, and we will discuss about this course. Next week we will discuss only your week 3 course content. Okay. So, all the best for your assignments. I hope you will now easily answer your assignment, okay, for the week 1 and week 2, and if any problem persists, please do contact me, and I will close today's session. So, thank you all of you, and let's meet in next week's session. Okay. Thank you. I am closing session for today. Okay. Thank you so much. Thank you all for joining.